Very good morning to all the participants in this refresher course on disaster management. Today in this lecture class, I would be talking about the status and issues of groundwater and its management. I would begin the lecture with a brief discussion on what we mean by groundwater. This would be followed by a discussion on what exactly we mean when we say water quality. This would be followed by a key discussion on water quality parameters, followed by groundwater management options and conclusion. So what is groundwater? Whenever we come across this particular term, it occurs to us that all water that occurs below the earth's surface is groundwater. However, that is not so. Water that occurs in the zone of saturation. In this particular schematic, what you see, you have this ground surface below which you have two different zones, the unsaturated zone and the saturated zone, demarcated by a dotted line, which is the water table. So all water that occurs within the zone of saturation or the saturated zone is the groundwater, as opposed to water that occurs in the unsaturated zone. So what is the difference between these two different zones? In the first zone, which is the unsaturated zone, which occurs right below the ground surface, the pore spaces within the rock matrix or soil matrix are partially filled with air and partially filled with water, as opposed to the water in the saturated zone, where all the pore spaces are filled up with water. So that is where we get the groundwater. Now, while discussing groundwater, we often come across this particular term, aquifer. Now, what is an aquifer? An aquifer is a water-bearing formation from which we could extract groundwater economically and sustainably. Now, it is an underground layer of water-bearing permeable rock. It could be a rock fracture or unconsolidated materials like gravel, sand or silt. So, now coming to this particular rhymer, this particular line which we have all at some point in time have heard, water, water everywhere, nor any drop to drink. Now this particular line is taken from the ancient rhymer by Samuel T. Coleridge, and he was a sailor and who got stuck in a becalmed ship in the middle of the sea, and all around he was surrounded by water. However, he could not drink any water from the sea. So any idea why he could not consume the water? In spite of he having a lot of water, yet he could not have any water from the sea. So the reason is because seawater is saline and it is not fit for consumption. So what he did was he could not have that water. So this particular line today underscores the situation in which different countries globally or also and also India is a part of it, faces in terms of water crisis. Like we have a lot of water, however, we don't really have water which is fit for consumption. Then these are baffling images which we keep seeing in newspapers, in television today very often, and there are a lot of reports coming up stating that making different predictions about the water crisis scenario. So this is from so in this particular report by in one of the reports, you get to see that a third of the world's population lives in water stressed countries now, and by 2025 this is expected to rise to twofold. So clearly 2025 is not too far, and the number of population getting exposed to water crisis would be still more. And this particular image was from 2019 from one of the tribal villages close to Maharashtra, where you get to see a woman, a tribal woman rappelling down a 6 feet long well to get water. So these are baffling images in the sense that, I mean, you could well imagine the crisis in terms of in terms of depletion of groundwater level. This depletion in the water level, groundwater level being facilitated by increased urbanization, overexploitation of the groundwater resource, increased demand of groundwater because of increased population, and also this being exacerbated by the issue of climate change, because of which there are reports of there today a lot of different states across India and also globally, people are facing drought like situation. There are erratic rainfall patterns today, erratic rainfall patterns happening, and so clearly putting a trust so clearly putting a lot of stress on this particular resource. So in terms of quantity, what I want to stress here is that there is a huge issue of water crisis in terms of groundwater depletion, in terms of water level going down, in terms of aquifers getting dried up, and added to this is the issue of water quality. So what is it that we mean when we say water quality? So water quality can be thought of a set of measures of the suitability of water for a particular use based on selected physical, chemical and biological characteristics. So physical parameters are parameters like turbidity, color, taste, odor and temperature. So these are parameters which we can talk about these parameters by a sense of smell, by merely looking into it, by a sense of taste. So these are physical parameters as opposed to chemical parameters, which are pH, electrical conductivity, alkalinity, hardness, total dissolved solids, fluorides, nitrates, metals, which could be iron, manganese, lead, etc., organics and nutrients, and saline water intrusion in coastal aquifers. So these are some of the chemical parameters, and apart from this you also have the issue of bacteriological contamination in specific areas where if the groundwater source is close to a septic tank or close to a sewer network, those sources could be affected by your bacteriological contamination. So, and the source of water pollution in general, both surface water and groundwater are natural and anthropogenic. Natural, when I say natural pollution, it means that because of the kind of geologic setup at the subsurface aquifers, or it could be a natural source of water. And anthropogenic is when because of man-made activities, the aquifers can get contaminated, like because of mining activities, because of effluents from industries. When sources get affected, that can lead to pollution, and those are man-made sources of pollution, and hence those are termed as anthropogenic sources of pollution. Now in terms of the geogenic sources of pollution, India today battles two specific contaminants, out of which I would be discussing, and those two contaminants are arsenic contamination in groundwater, and the second one is the issue of fluoride contamination in groundwater. So when we say arsenic contamination, so in most areas across India, groundwater sources are reported to have arsenic contamination above permissible limit. When I say permissible limit, that is the limit set by government, by the Bureau of Indian Standard, and also by WHO, which is World Health Organization, which sets a limit that if the drinking water source has levels beyond the set limit, then it is not fit for consumption. And the WHO limit and the BIS limit for arsenic in groundwater or drinking water is 10 microgram per liter. So this image here shows the areas across India which are reported to have arsenic contamination in the groundwater. So arsenic contamination in water, how does arsenic gets into water? If it's a geogenic contamination, it occurs primarily due to dissolution of minerals and ores. And in drinking water, it is found in mainly found in trivalent form, which is the arsenite form, and the pentavalent form, which is the arsenate form. And the effects of arsenic depends on the chemical form. Arsenic, the tree form, which is the arsenite form, is the most toxic form as opposed to the other forms. And fluoride, again, this map here shows the fluoride contamination across India, across different states in India. Out of 36 states in India, a total of 23 states are reported to have arsenic contamination in their groundwater sources. So, so clearly, fluoride again is a geogenic source of, and if fluoride contamination in water again occurs through the dissolution of minerals and ores, or of fluoride bearing minerals and ores. And weathering and leaching process, mainly by moving and percolating water, also plays an important role in increasing or decreasing the levels of fluorides in groundwater. And other factors such as the chemical composition, the presence and accessibility of fluoride minerals to water, and the residence time or the contact time between the source of minerals and water also governs the release of fluoride into water. So, this map here shows the population which are fluoride, shows the fluoride affected districts in India. Now, coming to, we have seen that how there is a huge issue of water scarcity, there is a huge issue of water quality. Then how do you move ahead in terms of, you know, managing this groundwater resource? Because this is a resource which we cannot do without. We have to, I mean, develop our groundwater resource, but how do we manage our groundwater resource? So, here are a few options. Aquifer mapping along with its characterization. It is important that we tend to map our aquifers. We trying to look into the subsurface hydrological setup of our aquifers. Formulation of aquifer management plan is important for facilitating sustainable management of groundwater resource at both the regional level and also at local level. And this has to be done through community involvement, and that means participatory management approach. We have to quantify the water available to us, along with also mapping out the status of water quality across the nation. Capacity building of functionaries like Panchayati Raj institutions, local communities, self-help groups in monitoring our water resource, our groundwater resource, our groundwater sources would be vital. And regulating and control of groundwater development. Today what is happening? Today there is a rampant use of groundwater resource. Okay, so there is a need that we form firm legislations. I mean, it has to be bounded by laws to put a tap on the amount of water that has been extracted from the ground. So that is also, that could also be one of a very vital groundwater management option. And in conclusion, awareness generation focusing on groundwater quality and health linkages, along with highlighting government's mitigation initiatives, would be vital. And this would be vital specifically in areas which are prone to contamination by geogenic sources, just as I have shown that the different states across India getting affected by arsenic contamination, contaminated groundwater, fluoride contaminated groundwater. So it's important that, you know, the initiatives for alternate sources are being spread across communities so that people don't consume contaminated water. So composite solutions through use of rainwater harvesting, water recharging, delineation and safeguarding of safe aquifers, reusing and recycling water, using smart technologies, smart systems, systems like metering would go a long way in the sustainable management of groundwater resource. And trust on integrated quality and quality assessment of water sources, followed by affordable and efficient technologies, treatment technologies, are becoming increasingly imperative. There is a huge need to, you know, invest in treatment technologies, affordable treatment technologies, to invest in technologies which are, you know, community friendly, which communities at the ground could use, could operate, could maintain. Okay. So with that, I would like to end my lecture today. So thank you very much for your patient hearing, and I'm open to any questions that you all have. Thank you very much.